So as we saw in the previous set of plots, we looked at mixtures, right? Applications that were made kind of in the middle of a treatment series, late fall, early winter, and ideally with more than one mode of action in the tank to help us on a resistance management front in a non-overseeded bermudagrass situation. This set of plots we'll look at now, this is part of a 4 replication trial. As we've done in all of our videos, we've tried to highlight 1 rep of that 4 replication study for you to really key in and see treatment differences. Here we're just going to look at some different mixture concepts with different AIs and kind of go through some additional approaches, particularly for mixtures that involve spectacle flow. Okay, so the first treated plot that we'll look at, this is a mixture of spectacle and tower. You've seen in other videos us talk about the early post activity that tower brings in a POA management plan. It's also an underutilized mode of action as a group 15 very long chain fatty acid synthesis inhibitor. Here, we're mixing it with spectacle flow at a lower rate. So we have 3 ounces of spectacle, 32 fluid ounces of tower. This was applied October 3rd. We use an emergence model to guide when we make our applications. We know through previous research that POA will germinate and emerge in 419 or in Tifway hybrid bermudagrass, I should say, when soil temperatures are 66 or cooler for a 7-day period, and we have some moisture within that same 7-day period. We start our applications here on October 3rd of 2024. Single application treatment, again, of spectacle flow and tower, doing fairly well. We move on to the next plot. Same idea, we've just increased our spectacle flow rate. Instead of being at 3, now we're at 4.5 ounces of spectacle flow. We'll go up 1 rate higher, so now this is 6 ounces of spectacle flow and 32 fluid ounces of tower. Next plot, we've added an ALS inhibitor to the mix. So now we've got spectacle at 3, tower at 32, and we're including katana at 3 ounces per acre into that treatment. Again, to kind of get at that pre-3 concept that's become so popular in the industry. Next plot is the same kind of idea where we've got spectacle, katana, and tower and mixture. We've just increased our spectacle flow rate from 3 ounces to 4.5 ounces. Next plot, all we've done, we've increased our spectacle rate. We're 6 fluid ounces of spectacle. We've got 3 ounces of katana, and then our 32 fluid ounces per acre of tower. Last 2 plots here, this is a newer herbicide, so this is StayGuard. It's a granular product. Active ingredient is flumioxazin, same active that's in SureGuard. What we have here, this is an October application of StayGuard at 200 pounds per acre. We can see that it's really started to break. It has activity on young POA plants and offers residual as well, but that residual is only going to be about a 70 to 90 day period at most. And we can see with an application in October, we're well outside of that now, and the results show that. Increasing rate isn't going to really help. We go from 200 now to 300 pounds per acre of StayGuard. We kind of get the same result. Our residual has played out. Can be a super useful tool, as you've seen in other videos, particularly if you want a non-root inhibiting program, but we need to have other things around it in order to have a total program that's going to give us that POA control to go from September through early spring in Knoxville. I think that's all for this one trial, looking again at multi-mode of action mixtures. We know that this is a really important part of any POA management program. It's not the be-all, end-all. We don't want you to think that one application is going to get you where you want to go. I think it's important when you look at any university research trial, Tennessee's included, you can see there's not a tree around me. We have no shade here. We have very little traffic. I like to joke with my golf course superintendent friends, our tee sheet is 0, 365 days a year. So there are other factors at play when you put these treatments out into the real world that we can't simulate at a research setting. We know that when you get out into the real world, we like to see a total program where there's an application behind some of these mixtures and then one after. If you have any questions or comments, you can leave those below, and thank you for listening.